Hi, Kevin at Ledoux Guitars. A few days ago, I did a demonstration on setting barrel nuts in the in the tenon of a neck. And there were a lot of good comments about that. Thanks for submitting those, by the way. And there was some interest on the part of several people in learning how to make those barrel nuts that I used to set in there. Now, I'll repeat from the last video. Barrel nuts are not uncommon. They are readily available, but you may need them or want them in a specific size that isn't readily available. And that's my particular situation. I'm not satisfied with these. These are 3/8 in diameter. Um, I'm going to use a smaller one. So I thought today I'd set up a demonstration and show you how I'm going to make barrel nuts to suit my own particular needs. Um, they are available in a lot of places, but if they're not available where you are, or if you can't get the size, maybe this is something that you can really use. What you'll need to begin with to make this tool, and moving forward, this is what we're going to make right here. You'll need a piece of strictly square stock in the hardest wood you have available. Now, I selected hickory because it's the hardest that I have available. If you live in an area or you have access to something that's more dense than this, by all means use it, because it's going to create a little more durability and longevity in your finished tool. Uh, I made a piece of this that was, I don't know, 10 or 11 inches long, something like that, because it's safer to run through my machinery. But also because if I make this and this wears out, I've got a little more stock left that I can make another one if I feel I want to make another one. Or maybe you want to make a second one for a second size. So um, I cut my stock for this thing, a blank, at 2¼ inches long. I think that could vary greatly. I don't think it wants to be too long, and you'll see why later, because it has to do with getting the rod in and out of this thing. But I cut mine at 2¼ inches. I guess you can see that there. And what's the millimeter count? There we go. 56, almost 57 millimeters. So once you have that, now comes the real precision work. By the way, as strictly square as you can get this. You want to work very hard at making these dimensions equal. But if you missed on that, there's still a way to work around that. What I need to do now is I need to find the dead center of the end of this block. And that sounds really simple, and I suppose it is. I could take a nice precise square. This is an old Lufkin. It's a real good one. I could square across there, just do the diagonal. But that presupposes that that block is, in fact, exactly square. So I could do that, and I can mark those positions. But I guarantee you, if they're not right, it's going to make the tool almost useless as soon as you drill the first hole. So here was my solution. Now, you may not have this available, but I'm going to show you what I did and then go back to something else that you might be able to do. I used this. This is my dial height gauge. You might have a digital height gauge. Might even be a little easier if you got a digital. And all I did was I measure the height of the block. I divide that number in half. And once I find that, and I'm not going to go through those calculations and movements for you right now, but once I find that, I'm going to strike that across the end of the block. And if the block is strictly square, I'm going to do it again. I'm going to rotate the block 90 degrees and score it again. What if the block is not perfectly square? No problem. I started with this. I started with one surface. I divided that distance in half, moved to it, and struck my line. If it's not perfectly square, then I'm just going to do the same process over again. Find the thickness of this, the height, if you will, divide that in half, and strike the line. And that will bring me to dead center in the end of that block. So I'm going to uh, do that off camera because I've shown you pretty much the way that works. And I'll get back with you when I have those scored lines. But what if you don't have a height gauge? What then? Well, there is a way that you can do this, and it's the old trick, uh, and this might actually be just as efficient for you. It's the old trick of finding the center of anything even if you can't measure. Using a combination square, I'm going to, as best as I can, center the square. This is 1 1/4 inches, so I want 5/8 on the square. And I'm going to strike that line. And I even did a short video on this very technique a while ago so that woodworkers could share this with their kids. And I have managed to put a line dead center on that. And I could refine that a little bit further. That line's a little dark. It's a little too thick, which means I could refine this more. But by doing that, I can then, of course, find my center thusly. And I can double check that by going around the square and touching on each surface. And as soon as I have that center line, everything is good. Now, here's the next big trick that I found when I made mine. And I did make one of these a couple of days ago. I made this one up, and it was a failure. And it was a failure because this hole ended up being just maybe a 32nd of an inch off center. And it was enough to ruin the whole thing. So I had to do it again. Now, at the intersection of those two lines, I want to put a dimple there because I'm going to drill that. And it's imperative that that point is absolutely, absolutely on that center. So I'm going to use a scriber first, and I'm going to reach in there. And if you're like me, you might even want to get a magnifying glass out. And I'm going to point that center exactly. Okay? And if I didn't do it right, if I didn't get it right, then I'm going to go shave a whisker off of that with a table saw or with a sander, and I'm going to do it again. By the way, you want the end of the block to be strictly square with the surfaces as well. We don't want this out of square at all. So I have that dimple there, and I can see that it's in the center nicely. And I'm going to take a center punch. I'm not going to use my automatic center punch like this because mine is quite large and it's quite resistant. So by the time I put a dimple in there, it's going to put quite a cone in there that I'd really rather not have because I'm going to use a brad point drill to drill this with. And I want the drill to find that center, but I don't want that dimple to be so large that the wings of the brad point drill hit that material before the point does. So I'm all centered up and I'm ready to drill. And I do want, while I'm at it, I want center lines at least on one surface of this thing all the way down through. So I'm going to put that on there and I'll be good to go. So here we are at the drill press. We're about ready to drill through this block. I'm using this small drill press vise, and I have a larger one, a heavier one, and you would think that weight would be to your advantage to get this thing to hold still, but it actually isn't, because I want that brad point to hit that spot that I put in the center of that block. And if that drill press vise is heavy, it's actually harder to nudge it and get it in the right place, where this will tend to find its own way and help assist in getting that nicely centered. And as I mentioned before, it's extremely important that that hole is centered. I'm drilling a 5/16 hole because I'm going to use a 5/16 rod to make my barrel nuts. That diameter could change for your particular needs. What if you don't have a drill press vise of any kind? You can still do this. I'm just going to move this and show you this rig here. I just took two nicely square, straight pieces of wood. Let's get that stuff off there. And I clamped a block between them. And I can see that needs a little adjustment there. But by clamping my workpiece between them, I can stand it up and keep it in one place. And when I do this, I take my square, and this applies to the drill press vise as well. I take a square and make sure that this is standing absolutely square to the table. Really, really important stuff. So even if you haven't got a drill press vise, you can still do this. So I'm just going to crank up and drill this thing here. I actually don't like some brad point drills. Some brad point drills are not as nicely brad pointed as you'd like them to be. There we go. After I drilled that hole 5/16 of an inch for my 5/16 barrel nut, I took the time to check that with my caliper all the way around to find out how closely centered I am. Because you want that to be as close to center as you can possibly get it. The reason being that you're going to drill right down toward the center of this. And if this is off center and you drill on the center line up here, if they're not perfectly, if they don't perfectly coincide, you're not going to drill the center of this. And you might get away with it, but it's going to look pretty ugly. So I have determined that I'm not perfectly centered, but one axis I'm within 4/1000ths of an inch. And for a piece of wood, that's pretty good. So since I'm centered this way by 4/1000ths, and I'm centered this way, I'm off by about 6/1000ths of an inch. I'm going to take this, so I marked it, that I'm going to drill here. So what I need to do now is drill through this piece of wood in preparation for drilling into the barrel itself. So my barrel happens to be 23/32 of an inch long. Yours may vary. I don't think length matters as much as what does matter is that there's a little bit of play inside there so that there's room enough for that barrel to slop back and forth, you know, just by a millimeter, maybe a 32nd of an inch, something like that, so that you've got a little bit of wiggle room. So I'm going to come in here half of that thickness, which I've already set up on my combination square here, and I'm going to score that, and I'm doing it with a scriber, but I'll redo it here with a pencil so that you can see that scored line, and there's the center line. And once again, I'm going to very carefully, with a magnifying glass if I need to, and I might, I'm going to point out that drill spot. And in this case, I am going to enlarge it again with my center punch because I'm not using a brad point drill. If you don't have a center punch, and if you're not sure about what center punches are, they come in a lot of different sizes, but I'd get one or two, keep them around. And get an automatic center punch too if you do anything in materials other than wood. They're really handy. So I'm ready to drill this. We're going to go back over to the drill press and do that job. So what I'm going to drill here through this block is the tap hole for the threaded hole in here, of course. Now, I don't want to be condescending or presuppose that nobody out there knows anything, but in the event that some of you who are new to guitar making or woodworking or any of this, maybe it's appropriate to explain that I can't just reach for some fractional drill and drill a hole through there. I need to have a drill that appropriately coincides with this number 10 24 threads per inch screw. This is the fastener that I'm going to use, so I need the appropriate hole. If you're not familiar with this, um, you will need at least this size, but you will need a set of numbered drills, 1 through 60. These coincide with wire gauge and they're used for all kinds of tapping purposes. So you also need to know what size, what particular number drill do you use. And so uh, I use my screw checker, which you don't need anything this fancy. Here is, let's see, here's a little plastic card one made by the LS Starrett company, but you can find tap drill size information all over online. It's going to be out there everywhere for free, so you don't need all of this stuff, but you'll find this in chart form in a lot of places. So I look at my particular chart. I'm going to drill a number 10. I'm going to drill for a 10, 24 threads per inch, and that's telling me that I need a number 25 drill, which I have installed, and I'm going to drill. I'm using my small drill press vise again. It's important that the drill gets properly centered on that mark, so I'm using a lightweight press so that the drill will find that. If I were on a milling machine or something where I had precise control of XY direction, I could zero in, but just for the drill press, that's harder. So a little gingerly alignment here is appropriate. And I'm going to drill this all the way through. I probably don't need to go all the way through this, but I'm going to do that because it kind of gives me a double tool. I got two sides to work from if I need that. So now I need to drill a hole behind that first one, that numbered hole. I need to drill back here to put in this insert. Now, this threaded insert is larger than I would like to use, but it's the only one I happen to have in the shop, and I'm not going to run downtown to buy another one. So I'm going to set this. Its purpose is to hold the rod still when I shove it in there to drill on its center. If I don't have a way to hold that rod still, it may rotate a little bit under the pressure of the drill. That could give you an off-center hole, obviously, and it could, I suppose, even gall and break your drill. So I'm going to put this in. Now, this happens to be a knife edge insert. These, excuse my hands here, these threads are very sharp. These won't hold anything in end grain. They only work in edge grain or surface grain. Um, but I'm going to put this in, as I said, because it's what I have, and it's actually stronger for this purpose. It requires, if I measure this barrel down here, it requires a 3/8 inch hole. But my experience with these has been if you drill a hole that's the same diameter as that barrel end, you're going to have nothing but trouble out of it when you try and drive it. So I'm going a 64th of an inch larger to drill that. I hope that was valuable information. But we're going to drill that. And this doesn't have to be super dead accurate as your other work did, but still, precision is always desirable. So now it's time to put an insert in that hole. And as I mentioned, this is what I have, so this is what I'm going to use. You could use, I suppose, any number of sizes. This one happens to be steel. Here's a brass one, oversized, of course. But a little background information that maybe you didn't know. I just found this out maybe a couple or 3 years ago. from the Hillman people. They package a lot of these types of fasteners. Um, these slots, which many of us over the years have presupposed were meant to be a slot for a screwdriver, that's not what they're for at all. These go at the bottom of the hole, and those slots are cut there to clear the swarf out when that threads its way in, and it ends up in the center of the hole, and you can just shake it out when you're done. Uh, I am going to put this one in backwards, however, because I do want to extract it, which I've done 2 or 3 times, and you can see that it's starting to bugger this up, but I'm going to use it for the demonstration anyway. So we need a way to put it in then. We can't drive it in there with a screwdriver. So here's what you can do. I take a piece of 1032 threaded stock here, just a machine screw, and I'm going to put a nut on it. And I'm just going to make myself a tool. You can buy a tool to do this with. Why buy when you can just make this easily, especially? Okay, and I've just threaded those together. Now I've got a way that I can put a wrench on this thing, and that's just what I'm going to do. So my hole is oversized. Now these things are still a pain because this is not going to set down on there nice and straight. You're going to have to put a little pressure on it. I'm sure you've had experience with these things before, and I'll bet you're as frustrated as I am. But by putting a little down pressure on it and trying to keep it sort of straight, you can put that right in there. Now, there's been some concern in the comments on the previous video about the strength of all of this. You can see that's not really straight. That's the reason I don't like these inserts. It's very difficult to get them beautifully straight. But for what we're going to do with this, I think this is going to be all right. And I don't even need to drive it in all the way. Just as long as it doesn't drop down into that hole, I'm pretty good. And it's nasty crooked, so I may pull it out after the video and redo it, see if I can get it straight. So now I'm just going to back the nut off. I was going to say, there's concern about the strength of all of this, you know, the strength of the threads in the barrel nut and so on. Just to give you an indication. You ever wondered why a nut is the thickness that it is? In the case of a 3/16 nut, that's 122 thousandths, roughly 1/8 of an inch. A 1/4 inch nut is thicker, 1/2 inch nut is thicker, and of course broader. The reason they stop the thickness where they do is because that number of threads in that nut is as strong as it gets. If they make the nut deeper, it does not get any stronger. So it doesn't take much for this to be really strong. And just that number of threads, that'll hold my weight easily. All right, so enough of that stuff. We've got this in here, and I'm just going to install my much hated thumb screw to act as a locking device, so to speak. And there we go. It's nasty crooked. I should fix it right now, but I'm not going to because I want to move on to the next part of our demonstration. Now this thumb screw that I'm putting in is going to hold that rod in position. So whatever you put in here, doesn't have to be a thumb screw, but whatever you put in there has got to thread down far enough, and I don't know if you can see this just on the camera. But maybe you can see that's going to penetrate in there so that that screw is going to come through the hole and be able to touch that rod and put some pressure on it. Here is our finished tool. I did take the time to straighten that up, by the way. I also took the time to wax the daylights out of the inside of that hole because it will benefit you. So now this is intended to hold this steel rod. And if you don't mind, a little background on the steel that you may be using. I don't know what this steel is. It's got a bright finish. It's been refined for some purpose. This is, you know, salvage steel. If you have to go down to the big box store or the hardware, you're more likely going to run into this this blue, gray, black, scaly color and texture that you feel on this is common. This is structural steel. It's not, you can't harden it. It won't take a sharp edge, but it's perfectly adequate for your purposes. It's just that it doesn't look as good. This is called hot rolled stock, and this is what will be in most of the metal racks. But you might find this, and I would prefer this, but it's harder to find. This is cold formed steel, and it's just got a nicer finish on it. And this might be a little bit different metal chemistry so that it machines easier, but that's really outside of our purposes. You just need to make sure you get the right size, and there's no reason why you can't buy the right size of this and spend a little time with some silicon carbide paper and clean it up a little bit. Just make you feel better if it looks better, I suppose. All right, so we're going to use this. What I'm going to do is I am not going to cut my barrel nut to length, not at all. What I'm going to do is there is the end of the barrel nut right there at the surface of that block. So I'm going to put a piece of steel in it, flush it down on my bench or any other place, and I'm going to use this thumb screw now to put some pressure on it to hold it still, keep it from rotating. And whatever you drive in there, I would have preferred an Allen screw, even a set screw, but I didn't happen to have one the right size, so this will suffice. But file that to a little bit of a point, maybe, uh, and that'll help. So that's just to keep that rod from rotating. So now we're going to go over the drill press, and we're going to drill this. So now we're all set to drill this hole, and we are, of course, drilling with the number 24 drill to coincide with the fastener that we're going to tap through that piece of rod. And I took the time before I turned the camera on to make sure that my drill and that hole coincide. I want that drill to be able to pass in and out of there with impunity. No dragging, no nothing, because that's going to help preserve our accuracy. Now, the drill is going to descend, and I'm going to want to get a grip on it as soon as it does, on the vise that is, and we'll drill through there. Now, I'm going to lubricate this because I'm drilling steel. I'm going to lubricate that drill. I'm using a little 3-in-1 oil, which is a lousy cutting oil. Cutting oil would be better for this, but I'm away from my machine shop area, and I don't want a lot of oil over here, which I would normally put on with a brush. So I'm just going to use a little of this. And don't be afraid about getting it down in that hole. That's not going to harm anything. In fact, a little oil on the tool is going to be to your benefit probably. Um, any lubricant for cutting is better than cutting dry. So now I'm just going to drill down through. And if you're not familiar with metal work at all, I don't want to get too aggressive with this thing. Give the drill time. Make sure that your drills are good and sharp. You can get away with a cheap dull drill sometimes in wood, but you can't do it in a piece of metal. It won't work. And we're through. All right, I have my 1024 tap and my tap wrench, and I'm going to attempt to thread nice and straight through that hole. A word about tapping. Don't try to do it dry unless you're working in something like nylon. Uh, and cutting oil, any oil is better than no oil, but cutting oil is best for this. So the trick is to just try and get a nice straight path down through there. There are ways that you can assure that that tap goes down through there exactly as it should. But my thinking right now is if you're working with home equipment and stuff in your wood shop, um, that stuff gets to be a bunch of stuff that you probably don't have. In fact, I'm not sure exactly how I would put this under the milling machine to try and line up, or the drill press to line up perfectly straight tapping. Um, I could do it, but it would take me some time to get it all oriented correctly. And a little bit of oil, and don't try and tap all the way through at once. You run in a ways and then pull back just to break up the chips and the swarf that's in there a little bit. You'll feel the resistance on the tap. I hope I'm not being overly ridiculous and simple with this, but I'm thinking that some folks might not have any experience with doing this. So if you already know how this works, then pay no attention to the man behind the camera here. So as you can see, um, it takes a little bit of time, and that's a good thing, because if you rush this, you're probably going to come up with a buggered thread that you don't want. And you'll feel the tap as it's pretty well completed what it's supposed to do. You'll feel its resistance decrease a little bit. These taps have a taper on them so that they don't just cut a full thread as soon as they touch the work. They kind of chew their way in and then cut a full thread. So there, I'm all the way through, and it feels good anyway. So I'm going to come back up out of there and test it with a machine screw to make sure I'm okay, and we should have it. Now the question is, I've got this long piece of rod. What do I do now? I got to cut it off somewhere, and I'm going to address that in the next segment. Put a piece of tape up next to your ruler. I'm going to move the cylinder over until I hit 23/32 of an inch. Push that down and just roll that on there. And you just need, a turn or so. I'm going to make a tab on the tape to make it easier to remove. And now that tells me where I can cut that off. Now, I have the luxury over here, as you can see behind me, of that power hacksaw. That's real nice, a little overkill for this. You could cut this off on a metal lathe, but you can just as easily put this in a vise, and with a hand hacksaw, you can cut that right off. So here's a pair of the finished barrel nuts made with this device. I think this is worthwhile if you have a need for a special size barrel nut or a special circumstance that you need to accommodate. I'm not positive about durability, but as I said earlier, the more dense the hardwood you make this with, I think the better chance you have for longevity. This is, without a doubt, a lengthy process and not really an easy one. So if you can solve this problem by just going to the hardware store, or you can, order from Amazon or McMaster Car or something, it's probably more worthwhile. But I am a person that likes to fiddle with this stuff, and if you're in a situation where you need to make one of these, why, maybe what I've shown you is helpful. Behind those, I have the larger 3/8 that I made the other day, and I just thought I'd show you. This is the counterpart of this tool that I use to make those 3/8 with. The hexagon stock works nicely because it will fit in a 3-jaw chuck in a metal lathe. Makes it very easy to get that hole centered. And then you can set this in a mill vise and clamp to these edges, and you can drill these holes conveniently. This is the set screw to hold on to the piece, and the piece gets shoved through there. And here's where I drill, for the tapped hole. And it's a nice little piece. It's easy enough to do, but if you don't have the equipment that you need to do it with, it just becomes really difficult. But if you're interested in seeing how I do this, on a metal lathe in a mill, put it in the comments. I'd be happy to show you this. So anyway, I'm going to turn and do, I think, another separate video right after this one on what I've learned about the strength of these things.